So, good afternoon, sir. My name is Sheikh Afrin Niha, and my register number is 241FB04203, and I'm from MTech first year. Today, I'm going to present the topic parallel and distributed computing. Now, let us move to the contents. First one is introduction about the parallel and distributed computing and what is meant by parallel computing and what is meant by distributed computing with examples. Parallel computing and distributed computing differences. What is a parallelism and next types of parallelism and finally conclusion. Now let us move to the introduction. Now these slides explain why parallel and distributed computing is needed. As data size and problem complexity grow, a single processor system becomes insufficient. So, a single system suffers from slow execution, second one memory limitation, third one poor scalability. Now, what is meant by parallel computing does here? It solves problem of faster by dividing work among the multiple processes. Coming to distributed computing, what does it do? It does the solves problems by using multiple computers connected via a network. So together they provide high performance, faster execution and better resolution. So better resource utilization. What is the key idea here? Modern computing problems demand more power than one computer can provide. Now, let us move to the parallel computing in detail. So, what is meant by parallel computing? Parallel computing is defined as multiple processors executing tasks simultaneously within a single system. Now, what are the main characteristics of it? Shared memory architecture. Second, tight coupling between the processors. Communication via shared memory. We can see in the diagram as I provided there in the slide. Like what is the goal here? Achieve speed up. Achieving the speed up, and it achieves the speed up along with the reduction execution time. So what is the parallel computing conclusion here? Focuses on performance within one machine. Now, let us move to the example of parallel computing. What is the example means? Multi-core processors, GPU computing, scientific simulations. Now, let us explain. Let me explain the in very detail. Like multi-processor, it have the modern CPUs have more multiple cores. Like a GPU computing, thousands of cores for massive parallelism. Now for scientific simulations, weather forecasting and molecular modeling. So these are the some examples show the real world usage of parallel systems. Now let us move to the what is distributed computing. So distributed computing means what here? Multiple independent computers connected through a network. So each system has its own processor, its own memory. They work together as a single logical system. So what are the key features here? Message passing communication. Second one, no shared memory. And third one, high fault tolerance. So can we see in the diagram also? So focus is on scalability and reliability. Next, coming to the examples of it, like the major examples include first one cloud computing and next one Hadoop and next one distributed databases. So first one cloud computing, it like AWS, Azure and Google Cloud, and Hadoop. Coming to Hadoop, like it is distributed storage and processing, and coming to distributed databases, like data stored across multiple locations. So these are the some examples. These systems handle the use data on large user basis. Now move to the parallel vs distributed computing. Now, what are the differences between parallel and distributed computing? Means the slide, it highlights the key differences like system type and fault tolerance and examples and programming models like and memory and communication, etc. So mainly parallel computing explains the single system and shared memory and faster communication, whereas in distributed computing it contains multiple systems, network communication, better fault tolerance and scalability. So I have mentioned some differences also like distance and speed and scalability and cost also. Now, what are the use cases means what here? Scientific simulations, image processing, in parallel computing, whereas in distributed computing, big data analytics, and web servers, services, etc. Now, let us move to the what is meant by a parallelism. Parallelism. What is meant by parallelism? So, parallelism refers to the ability of a system to perform multiple operations at the same time. Like instead of executing tasks sequentially, one after one another, tasks are executed simultaneously. So parallelism focuses on speed improvement, reduced execution time, like it is achieved using multiple CPU cores, multiple processors and GPUs. For example, adding two arrays using multiple cores at the same time. Now, what is a core concept here? Means parallelism is about doing many things at once. Now, move to the types of parallelism. So here in this slide introduces the three main types of parallelisms. First one, data parallelism, task parallelism, pipeline parallelisms. These are three parallelisms. So these types describes how work is divided among the processors. So choosing the correct type depends upon the nature of the problem, data dependency, hardware architecture. Now this is a roadmap for the understanding parallel execution models. Now let us move to the data parallelism. Now, the data parallelism means the same operation is performed on the different parts of the data simultaneously. Like data is divided into chunks. You can see in the data parallelism diagram. I have mentioned there in the slide. Like data is divided into chunks as task 1, task 1, task 1, task 1. Like each processor works on the separate chunks. And for example, matrix addition. So each core handles different rows. For in image processing, like applying the same filter to different parts of the image. So what are the advantages of this? Simple to implement, highly scalable and common in GPUs and machine learning models. Next, key point. What is a key point in the data parallelism? So coming to this key point, same task, multiple data sets. Now, task parallelism. It is one of the type of the parallelism. So task parallelism means different tasks are executed simultaneously. So each processor performs a different function. Now we can say in the example like web server. One thread handles user requests. Another manages database access. Another handles logging. So what is the advantage here? Suitable for complex applications, good for multifunctional systems. Now coming to what is the limitation here? Tasks may depend on each other, causing synchronizes issues. Now, coming to what is the key idea behind it is different tasks run at the same time. Now, turning to pipeline parallelism. Here, the parallelism works like an assembly line. Like parallelism, a task is divided into stages. Stage 1, stage 2 and so on. Like each stage is executed by a different processor. We can see in the diagram. Output of one stage becomes input to the next step. Next example. Here CPU instruction pipeline like fetch, decode and execute and write back. Now, what is the advantage and what is the limitation? So coming to advantage, increases throughput, efficient use of processors. Next, limitations. Slowest stage becomes a bottleneck. Key idea behind that is different stages executes simultaneously like stage 1, stage 2 and so on. Now, moving to applications. I would like to discuss some applications of the parallel and distributed computing. It is widely used in many real-world applications like AI and ML, that means artificial intelligence and machine learning, big data analytics, weather forecasting and scientific research. Like AI and machine learning used to train the large neural networks faster by processing the data in parallel on GPU and distributed clusters. So big data clusters means in big data analytics, technologies like Hadoop, Spark processors and massive data sets by distributing tasks across the multiple systems. For weather forecasting, complex climate models require high-speed parallel processing to analyze large atmospheric data accurately. For scientific research, coming to the scientific research, use it in simulations like space research, bioinformatics, physics experiments that require the high computational power. So these are the some applications demand on high speed, scalability, efficiency, which parallel and distributed systems provide. Now, coming to the conclusion. So finally here, parallel and distributed computing, it plays a very crucial role in modern computing by improving the performance through the simultaneously execution by providing scalability to handle the large problems and data. Now increasing the reliability through the fault tolerance. It is one of the crucial modern computing role. These are the some essential for handling today's complex and data intensive and time critical applications, making them as a backbone of modern computing systems. So thank you.